that we're not doing a system here, we're getting from one step to the next. So example, example, guess. Therefore, it's a inductive reasoning. Especially when the statement is actually false, it's going to be an inductive reasoning. Well, that's the second lesson. The third lesson is on finding midpoint. Formula for midpoint is to add the x's, divide by 2, add the y's, and divide by 2. So, for example, if we have 3 points, A, B, and C, I could say find the midpoint of AB and find the midpoint of BC. We could draw a diagram, but you really don't need to. I don't think it's that important. So first AB. So we're going to add the x's. Remember, the x is the first number. 1 plus 5. Then we're going to add the y's. Add the x's and divide by 2. Then we're going to add the y's. 2 plus 2. And again, the formula tells us to divide by 2. 1 plus 5 is 6. 6 divided by 2 is 3. 2 plus 2 is 4. 4 divided by 2 is 2. So this is the midpoint of AB. BC, this is going to be done the exact same way. We're going to add the x's for B and C. So 5 plus 3. And again, make sure you divide by 2 because that's what the formula says. And then we're going to add the y's. 2 plus negative 1. Negatives make it a little harder. Use a calculator if we need to. 5 plus 3 is 8. 8 divided by 2 is 4. 2 plus negative 1 is 1. 1 divided by 2 is 1/2. Now you can make that 0.5 if you want. That doesn't matter. So that's midpoint. Median. All right, there's a lot of definitions for median. Here's a new one that we haven't seen this year. It's a segment in a triangle connecting vertex to midpoint of opposite side. All right, so there's a few definitions in this definition. This one we do want to draw a diagram for. So what are we talking about? We're talking about a triangle here. And I'll just label it ABC. A segment connecting a vertex. A vertex is where two lines come together. There are 3 what are called vertices. That's plural for vertex. There are 3 vertices in a triangle. So we're going to draw a segment from the vertex to the midpoint of the opposite side. So we pick any vertex. Here's vertex A. And I'm going to draw a segment to the opposite side, which is BC, to the midpoint. I'll call this D. Now, again, in geometry, we can't assume things. We have to have labels in here. So right now, D is not the midpoint. What the midpoint means is that it's directly in the middle, which means this little segment has to be congruent to this little segment. How do I show that 2 segments are congruent? Tick marks. Remember that from the previous lesson. You got to put tick marks to show that they are congruent. Now we only need to draw in one median, but I'm going to draw in all 3 of them. There are 3 medians because there are 3 vertices. So we can draw a line from B to the opposite side, AD. And again, I'll just call this letter E. Now to show that this is a midpoint, we don't want to use one tick mark because what this is saying is that all 4 of these little segments are congruent. We don't know that, and they don't need to be. I just need to show that these two segments are congruent, so I use a different mark than what I used here. So I'll make 2 marks here. So these are congruent, but they're not necessarily congruent to these two. And then the last segment, and they should intersect all in the middle, not that it matters that much, but from C to the other side, I'll call that F. Again, to show F is the midpoint, I need to show that these are congruent, not necessarily congruent to those, so I'll put 3 tick marks. So basically, AD, BE, and CF are all medians. Another definition, perpendicular bisector. That's a segment, it's almost the same definition, in a triangle connecting vertex to midpoint of opposite side. So if you notice, I've written exactly the same thing so far, but there's a little bit more. And is perpendicular to the opposite side. All right, so let's draw this one. So again, triangle. I'll just label it the same, ABC. So I want to draw a segment from the vertex to the midpoint of the opposite side. All right, so that will be exactly the same. To show that it's a midpoint, we use tick marks. But now I also want to show it's perpendicular to the opposite side. So I want this line to be perpendicular to this line. How we show that is with right angles or boxes. So without the boxes, it's a median. With the boxes and the tick marks, it's a perpendicular bisector. Like the median, there are 3 of them. Draw a line here. The tick marks say that it's a median. The box makes it a perpendicular bisector. And then from C over here to F. If you just draw in the boxes, that is what is called an altitude, which I guess we don't need to know in this chapter. With the tick marks and the box, it's a perpendicular bisector. So in this diagram, AD, BE, and CF are all perpendicular bisectors. One other example we want to look at in this lesson is we did problems where we found the midpoint, but sometimes they might give you the midpoint and you have to find one of the other sides. Given midpoint and one of the endpoints, find the other endpoint. To me, the best way of doing this is to act it out. So this is where the diagram does help. So when they give you the midpoint, I think it's a good idea to draw the diagram. Again, we don't have to have it perfect, but 2, -1 would be here. Let's just call this M and whatever A. Again, it doesn't matter what you call it, but probably good to call this M for midpoint. So 2, -1 would be around here. 6, 1 would be over here somewhere. Now remember that M is the midpoint. So the other point wouldn't be over here because that would make M the endpoint. So if this is the middle, the other point's over here somewhere. Now I don't want to guess, but at least I have some idea where it should be. Looks like some of these numbers should be negative, if not both of them. All right, so put your numbers in. That was 6 comma 1. This was 2 comma -1. And really, you can just do some mental math, or I mean, you could punch it in a calculator too, but you just need to figure out, how do I get from the x number to this x number, and then do the same thing down here. So from 6 to 2, how do I get from 6 to 2? Basically, I subtracted 4. Okay, well, now I need to subtract 4 again. So 2 minus 4 is -2. That kind of looks like it's in the negative, so that seems like it's the right answer. Now you do the same thing with the y value. Here's 1. I need to get to -1. How do I do that? Well, that subtracted 2. Okay, well, do the same thing. Subtract 2 again. So -1 minus 2 is -3. So your other point is at -2 comma -3, which again, based on my diagram, looks like it makes sense. That's lesson number 3. Then the final lesson of the week is 11.3. Area. Really, it's area and perimeter of figures. Some of these should be easy, some might be a little hard though. So we have, it looks like 4 different figures. Circle. The area formula is pi r squared. R stands for radius. The perimeter is usually called circumference for a circle. I mean, you can call it perimeter, but the fancy term is circumference, is 2 pi r. And again, r stands for radius. Pi is a number that's approximately 3.14. It's an irrational number, so it goes on forever and never repeats, but it's approximately 3.14. We don't technically need to know that, but it's good to know. All right, so let's do an example. The radius is the distance from the center to the circle. In this case, the radius would be 5. So let's find area and perimeter for each problem. So we're going to do several examples. All right, so to find area, we're going to plug in 5 for r. And to me, I would just keep it in terms of pi. And this way I don't even need a calculator. 5 squared, 5 times 5 is 25. Now the answer is not 25. This has to tag along too. You can put the pi in front, but it probably is better to put it in the back, kind of like a variable. So you can say pi 25, or you can say 25 pi. Now I'm not going to use units today, but if I were, any area problem would be units squared. So maybe this will probably be the only time I write this down, but units squared, like centimeters squared, meters squared, whatever. Area is always units squared. Where perimeter, or fancy term circumference, 2 pi r, this is just one big multiplication, 2 times pi times 5. Again, we can multiply the 2 and the 5 to get 10, and the pi just takes along. Perimeter is just singular units, so like centimeters or miles or whatever. Again, all these problems were finding the area and perimeter. Here they give you what is called the diameter. The diameter goes from one side to the other side through the center. So the diameter is twice the radius. I could give you another formula, but to me it's just easier to just cut this number in half. So if the diameter is 14, the radius is 7. So now it's the same problem as the other one. Just plug in 7 instead of 5. So again, area would be 7 squared, which is 49, with pi attached to the end of it. Circumference is 2 times 7, with pi attached to the end of it. And that's a circle. Next figure, rectangle. Area formula is length times width. Now, I could give a perimeter formula, but I just say add all the sides up. So, I mean, whatever. They could give you length plus width times 2 or something like that. To me, I wouldn't even bother with it. Just add up all the sides. All right, to show that it's a rectangle, we need the boxes. And the opposite sides are the same. So if it's 3 here, it's 3 there, 5 there, it's 5 there. So I don't need a formula for perimeter. I can just simply add those up. It doesn't matter if I want to add 3 and 5 and times it by 2, or add whatever, 5 times 2, 2 times 3 and add that, or just simply add the 4 numbers together. So whatever you think's the easiest, but there's nothing wrong with just adding these 4 numbers together. Somehow we get 16 out of it. So I don't think we need a formula. So I usually don't even give a formula for rectangle, for perimeter of a rectangle. Area is just length times width, which would be 3 times 5, which is 15. Square, if you remember from the previous lesson, all squares are rectangles. Well, if all squares are rectangles, they must have the same formula. They technically could use a different formula, like area could be s squared, or perimeter could be 4s, but why learn more formulas when it's basically a rectangle? So I think it's just best to use the same strategy with a rectangle. So we'll do an example, but let's just do it like it would be a rectangle. So to show that it's a square, it needs tick marks and boxes, and just put a number there. All right, well, perimeter, we know that they all have to be the same, so whatever. I mean, there are other ways of doing it, but you could just add the 4 fours together. So if you have other ways of doing it, that's great, as long as you get 16. Area, okay, length times width, 4 times 4, 16. Now that's just coincidence that those are the same. Let's just do a different one just to make sure we understand that. Whatever, 6. The perimeter would be, whatever, 6 times 4, add 4 6s together, that's 24. And the area would be 6 times 6, which is 36. So that was just more coincidence that those had the same answer. They normally will not. Okay, and then the last figure is a triangle. This actually can get kind of challenging. The formula is for area is 1/2 base times height. Again, for perimeter, just to me, add the sides. All right, I'm not even going to give you a formula. Add sides. We don't need a formula. Basically, the formula would be a plus b plus c. All right. Now, this is not terribly challenging if they give you a diagram like this, where it's all given to you. So to find the perimeter, we add the sides, 3 plus 4 plus 5. And that would be 12. Area is a little harder. Base times height. Basically, base and height could be length and width. These are interchangeable. Basically, you want the 2 sides that are next to the right angle, because technically they are all bases. 5 is a base, but there's no right angle drawn for it. So like, if I just turn this on its side here, this is the same triangle. So 5 is a base, but we don't see the height from it. It's not next to the right angle, so it's the same triangle, but we have to multiply the two numbers next to the right angle. So that can be a little tricky. So 3 times 4 is 12, half of 12 is 6. Okay, now it gets even, I think, a little bit harder when they give you a diagram like this. That's a 24. This isn't drawn to scale, but that's not that important, but just to let you know, it's not drawn to scale. Again, the perimeter is the distance around the triangle. So there's only 3 numbers that we want. We want the 3 numbers on the outside. So we do not want the 24. So we add those numbers up, and that's 108. Now the area formula, I'm just going to write down the formula again, base times height. Again, these are all bases. All right, I could redraw this. This is the same triangle. I almost wish I would have drew this one first. So we don't now say, oh, 26 is the base. They are all bases, all 3 of them. But we, again, like the previous one, we need to use the numbers that are next to the right angle. So there are 4 numbers up here. We only need 2 of them. We need the base that's next to the right angle. Well, that's the 42, no matter which diagram we're looking at. 40 and 26 do not have a right angle next to it. So we need to use 42. And the height from that right angle is actually this 24. All right, need a calculator for that. And I don't have my calculator in front of me. Just hold on one second. All right, so 1/2, which is 0.5, times 42 times 24, 504. All right, last example. This triangle is even a little harder than the previous one. Again, I just want to say it's not drawn to scale, but again, that's not that important to know, but just so you understand. All right, so we got a bunch of numbers here. So again, we want the perimeter and area. So perimeter involves 3 numbers. We want the 3 numbers that are part of the triangle. Well, the solid line is the triangle, so these are the 3 numbers we want to add together. 12, 11, and 4. Here comes the hardest part. We need the 2 numbers that make up the base and the height. Now the base has to be, again, there are 3 bases, so we have to use one of these numbers. Which is the one that's closest to the box? Well, that would be this one. This is the base we're using. It's not because it's at the bottom, it's because it's on the same line as the box. The 2 means absolutely nothing. I just put that in there to confuse. The 4 is the base. Now here's another part that's pretty tricky. The height has to be going straight up at a 90-degree angle. So 11 is not the height, it's called the slant height. The height is actually straight up from the right angle. So the 9 is actually used for the height. So again, the base is 4, the height is 9. 36, half of 36 is 18. And that's the final lesson of the week. Then on the Friday, we would have a quiz. Here's the quiz. Pause it if you need to. And then here's the answers to the quiz. Oh, I forgot to give you the worksheet. I'll do that next. All right. The worksheet for Thursday's lesson is right here. All right, that's the whole week for algebra. Have a good week.